Hi everyone, let's look at the next representation for the convolutional code. It is quite simpler to understand since we have seen the earlier unit what is the prefix code, how to go for the prefix code, uh, that is called in terms of the prefix code tree. Similarly, we have seen earlier what is Huffman tree. So in the same way, we'll see how to represent the convolutional code in terms of the tree diagram. So this is what the tree diagram. This is also called as a code tree diagram. Now, by considering this example, which we have seen in the earlier case also, if let's say the input bit is 101, we have seen in the earlier case that the output which we are getting that is of this kind means 111000, and these supplementary 4 bits are to have the direction towards the initial state is at the 00. That's why this additional uh, 00 bits will be added to the input bits and corresponding output bits will be 10 and 11. Now we will see how to means get this with help of the code tree or simply the tree diagram. So as the diagram is named as a tree diagram, if you just concentrate you will find that it is like a binary tree, means when we just travel to the upward side it is indicating that the input will be 0. When we travel to the downward side it will indicate that the input bit will be 1. So same will be applied in the upper part as well as to the lower part. Now let's proceed for our example, means the if input is 1 0 and 1, for input bit 101, what could be the probable output? So here let's say the input bit at the start it is 1. This is what 1. So if the input bit is 1, initial state is 00, so the output bit will be 1 1. So that is what mentioned over here, and next state is nothing but 10. So here for this entire code tree it is quite clear that these first two bits everywhere is nothing but the xy values of x and y, which can be obtained from this diagram, that is convolutional encoder circuit. And the second bits with the slash that are mentioned as a next state is from the 00, when the input bit is 1 the next state is 10. So that is what mentioned. The same thing is done in the rest of the part. So if you just concentrate with the colored figures, then you will be able to understand how we can proceed for this 101 input and how the encoded output will be obtained. Okay, now for input bit 1, this is what the corresponding output. So from here if I travel to the upward side it means I am tracking for the input bit 0. So that is what we have seen. If we travel to the upward side it means we are going for the input bit 0. If we travel to the downward side it means we are going for the input bit 1. So same is applicable to the entire diagram. So here after this it is again 0. It means I need to travel to the upward side. Now for the 10, since this is the next step, right now to traverse for the next condition, this will be acting as a present state. So 10, for 10 when the input is 0, when the input is 0, since this is what the second bit, the output bits will be 10. So that is what mentioned here, and the next state will be 01. So next state will be 0. So this is how the output, if we look corresponding to this one, will be what? 1 1. So this is 1 1, and next output bit corresponding to 0 is nothing but 1 0. Now let's track it for the 1. Right now we are at this particular point. So here from this point if I want to track for bit 1, it means I need to proceed the downward side. So here I will get the output bits as a 0 0. For this the output bits will be 0 0, and the next state will be 10. So this you can track the table. With the help of the state table also we can track it. Let's see here. 0 1, if it is 0 1 and the input bit is 1, the output bits are 0 0 and the next state will be 1 0. So that is what mentioned. Similarly we can track it for the next. Means if someone asks you, let's say, what will be the encoded output for 1011 for this figure again. So for 1, it means again from this side I need to go to the downward, since it represents moving with the input bit 1. So here input bit 1, it means again the output bits correspondingly 0 1 has to be over there. So this is what 0 1. Okay, so this is what all about how to track the encoded output with the help of the code tree or simply the tree diagram. This is quite simple to understand. Just the movement of corresponding bits should have been understood. Means 0 move upward, 1 means move downward. So here for the upper part it is quite same. Means 0 0, if the input bit is 0, output will be 0 0, next it will be 0. That's why we can observe over here it is same kind of repetition. So this is what all about this. We can say this another format to represent convolutional code. Thank you everyone. Thank you very much.